Hello guys, welcome back to our Cisco Lab series, and in today's we're going to look at a lab on OSPF, a single area. So you must first of all you need to understand what is an OSPF and why do we need OSPF in our networks. So OSPF is a routing protocol which has replaced the old technology that we used, that is the RIP. So OSPF has several advantages over RIP. What you have to know that OSPF is a link state protocol, while the RIP use a distance vector protocol. So there are several advantages of OSPF. It uses the area, and also it has what is called, introduces what is called an autonomous system. Also, it uses VLSM and also classless interdomain routing, where the network is very scalable and also flexible. So those are one of the advantages of OSPF over other routing protocols like the RIP and EIGRP. So OSPF with those advantages is the most currently used routing protocol in our network because it implements single area and also uh, multiple area. You can use multiple areas. This help reduce the size of the routing table because we have several routers in our network. So with that said, so if you look at this our topology, I've picked just this router. I'll show you how you can set up this topology. I've already set it. So what you can do, you can just pick the routers down here. Just pick the router, then you connect them with the serial interfaces. Like let's say we pick a router, this router here, and you want to connect it with a serial interface. When you look at the interface of that router, you can only see gig 0 and gig 1. So means that you don't see serial interfaces. But in this our topology here, these two interfaces need to be connected with a serial interface. So you just come to this your router here, go to the physical view, there, then use HWIC2T. Then before you change, you have to power off this that router. Then you drag that module up there. Then you power it on again. Come again, do to this other router. I go to the see, power it off. Bring this module up. Then power it back on. Then you're going to come and pick your serial port. So DCE. So you connect to that serial. You see now it has come up. The serial has serial 00 and serial 001 has been added to this router. Then you add that router. You see also that our serial has been added. So it's just that simple. And I know how do you connect a serial a gigabit Ethernet. That was just simple. But the where we normally have issues down is the serial port. So we are going to delete that. So we are going to work with the topology that we've set up here. With that topology, we say this is a single area where we have got area 0. So area 0 is where we are going to configure different networks and also the OSPF processes. So it is very, with area 0, the configuration is very simple because all the networks belong to this same area. So we're going to start with this our cooperative router, then we go to our SF router, then to a ALA router. So first of all, what we need, we are going to bring these interfaces up. You can see these interfaces are still in red. They should turn to green when they're up. When the status is up and also the protocol, you ensure that the protocol is up. The status must be up, but when the protocol is down, that interface means that the interface won't be able to come up. So you must ensure that the status of the link is up and also the LAN protocol is also up. So we're going to start with this our cooperative router. We go to the CLI. Say no. Now what we do, enable command. In our enable command, we use config terminal to get into the configuration. Config terminal. While on that, on the global configuration mode, we are going to set the host name for that router. So host name here, host name we said this is a COP router. While after that, you make sure that every time you log in into a device, you set up the security, because while you are working in an organization, you should not just leave your router in a scenario where anybody can just log in into your router and tamper with the router. So ensure that you always configure security on that router. So after that, the next thing I'm going to configure is no IP, domain main lookup. After that, after we configured that, the next thing now we do now is like, let's now configure the security. So we're going to set the security. So enable, when you log into that router, enable secret here will be, this is, let's just use OSPF. OSPF small case OSPF will be our secret. So every time you log into that, while you enter into the console, you'll now type that password. So then you create on the console interface, the interface that you configure the router. So enter interface, no, line console 0, password. Password here we can set password to be OSPF1. OSPF1. Then we tell it to log in every time you log in. Then also use this command logging synchronous, so that the message don't pop up every time you are typing. So after that, you can also create a VTY, and also for the remote logging for the telnet. So you create you're going to use line VTY 0 to 4. Then password here will be OSPF2. Then login. Yeah, you can also type the logging synchronous. So logging synchronous. After that, the next thing, make sure also you set the banner. So you exit and set the banner. So in your banner, you can say banner message of the day to be, you can use the $sign. So then you set the message of the day, the one you want to appear. So you can say this is a COP router. Enter. Then you end with the $sign. So then we are going to exit and see if all the configuration that we've set on that the security configuration has taken effect. So exit. Then you exit again. Now you can see here it's telling you now this is a COP router. So let's now log in into that COP router. Will be Cisco console password was not Cisco, OSPF1. OSPF1. Then enable. The secret word was OSPF. After that, you configure config t. Now we've set the security on that interface. So because I have showed you how you can configure the security on a router, you won't need to configure it on those other routers. You just know that every time you have to do this thing in a real world scenario, make sure you configure security on both of the routers. But I just use this cooperative router as an example. But those other routers will just need to configure the interface and give them IP addresses. So now we are going to configure IP addresses and bring the interfaces up. So enter interface. While you are on this computer, I've got three interfaces. Two of them are serial and one is a gigabit interface. So interface gig 0/0. I'm going to give it IP address of 10.10.10.1. Subnet is /24, so will be 255.255.255.0. So also you tell it no shut to bring that interface up. So we are told here the status has changed to up. It should, for that interface to be fully up, it should tell you the interface status is up and also the protocol is up. So it can still read. So make sure you configure both sides of the link for that interface to be up. So come to this boulder router. Say no. So enable, then config terminal, then host name here. This is a boulder router. After that, you enter the interface. So interface here will be interface gig 0. The IP address is .2. So interface gig 0/0. IP address will be 10.10.10.2. A mask of 255.255.255.0. Then tell it no shut. So now you see the status has changed to up, and also the line protocol. The line protocol has also changed to up. The line protocol interface is also up. So now let's see if it has turned green. You see, the interface has now turned to green. So also come to this and configure the serial. So exit. So interface serial 0/0/0. IP address of that serial will be 172.16.10.1. Vatican mask of 255.255.255 dot /30 will be .252.252. You should also know how you subnet. So after that, we also configure serial number 1. IP address will be this one will be now 172.16.10.5 with the same subnet mask of 255.255.255.252, because we need to configure on both links for that interface to be up. Sorry guys, we need to tell it no shut. So status has changed to up. So you tell serial 1 no shut. Then also go to serial 0, tell it no shut, and do shutdown. So that is the same as tell it bring that that interface up. So come back to SF router here. So enable config terminal, because we don't need to configure all of those other security, we just need to configure the interfaces. So interface serial 0/0/0/0. IP address here will be 172.16.10.2. Wildcard mask is 255.255.255.252. Then tell it no shut. Let's see if the interface has been up. Now you see it has turned to green. Then we configure the interface that connect to the PC. So that is gig 0. So interface gig 0/0. IP address is 192.168.10.1. Wildcard mask and a subnet mask of 255.255.255.0/24. Tell it no shut. See, the interface is now up. Come back to this other router. Go to the CLI. Tell it no. Enable to enter the privilege executable mode. Then use the config terminal to enter the global configuration mode. Then you enter interface view. So interface serial 0/0/1. IP address is 172.16.10.6. Subnet mask of 255.255.255.252. Then tell it no shut, and that no shut. That interface should come up. It's already up. Then configure the interface that connect to the PC number 1. So interface gig 0/0. IP address is 192.168.20.1. 255.255.255.0. Tell it no shut to bring that interface up. So all the interfaces have been brought up. Now we'll get to our PC and give them IP addresses. IP address is 192.168.10.10. Gateway will be one that is on router SF router. So 192.168.10.1. Then come to this other route. This other PC. Give it IP address of 192.168.20.10. Gateway is 192.16.20.1. With everything set now, let's look at some commands here. So verification command here. So exit again. So show show IP route. When you show IP route here, you can see we have got these networks. All these networks are directly connected. So we have got this network directly connected, all are directly connected to our router here. So after that, that's where now we are going now to implement OSPF and see how the OSPF works. So when you look at here, there's no OSPF on that router. So that's now where we are going to start. So you are on this router, we're going to advertise three networks. That is this network, and that other network. So it's very simple. Just enter to the global configuration mode, config terminal. So in the global configuration mode here, we're going to set a router OSPF process of 1. So you know OSPF process runs from OSPF runs from 1 to 65,535. So you can pick any value, and there's a very interesting thing here. So you can configure different OSPF number on these different routers, and it will still work very well. So you can configure this router with a different OSPF number, this one with a different OSPF process, this one different OSPF process. But still, at the end of the day, all your OSPF network should work properly. So here we're going to use OSPF process number 1. OSPF process number 1. Then the networks that we are going to advertise are a network of 172, that link to the SF router 172.16.10.1. We are going to use the interface specific based OSPF. Then our wildcard mask is 0.0.0.0. So with because this is a slash 30, we can just use a direct one. This is slash 30. Its wildcard mask will be 0.0.0. So I've put so many zeros. 0.0.0 slash 3. That is the wildcard mask of that slash 30. So we know that wildcard mask is used in OSPF and also in SCL. So you should understand very well how you use wildcard mask and subnet mask. Know the difference between the two. So then after that, you use the command area, then question. So with area runs from 0 to 4.2 billion. So you can set any integer from 0 to 4.2 billion, or you can also set it in a form of an IP address. So this one is a form of IP address. So we are going to set our area. Our backbone area is area 0, because as in our topology tell us area 0. Then also we advertise the network that connect to LA router. So network of 172.16 dot 10 dot 5. Its wildcard mask will be 0.0.0.3. Area here is area 0. Then again, we address the network that connect to the bold router. So network of 10 dot 10 dot 10 dot 10 dot 10.1. Then the wildcard slash 24 wildcard mask will be 0.0.0.255. In complete command less, then you specify the area 0. With that, we are done. Now go to this your boulder router here and finish with the OSPF. So enable. Now config terminal here. You tell it router OSPF process number 1. Then we attach the network of 10.10.10.2 wildcard mask of 0.0.0.255. Area here is 0. So you see here, the status has changed to up to full. The status here is full, and the neighbor is 10.10.10.2, and meaning that the OSPF has been established on that link. Also come to this side, the process ID is 1, status is full, has changed from loading to full, then the neighbor is 172.16.10.5. Come to this our SF router. So on SF router, we're going to enable, then config T. After that, we are going to create the OSPF process. So router OSPF process ID here is number 1. After that, we address the network of 192. That connect to the PC 192.168.10.1 subnet mask wildcard mask of 0.0.0.255. Area here is area 0. Then advertise the network that connect to the COP router. So network of 172.16.10.2 wildcard mask of 0.0.0.255. Area here is 0. It should also establish a neighbor adjacency. Should establish adjacency. So here you see here, the status has changed from loading to full. So loading is done. So then the neighbor here is 172.16.10.5. That is the interface on the COP router. So come back to this other router. So exit. Then tell it router process ID here, OSPF process number 1. On OSPF process number 1, you give it the network of 192.168.20.1 mask of wildcard mask of 0.0.0.255. That is the network that connect to the upper PC, area 0. Then address the network that connect to the COP router. So network of 172.168.10.6 wildcard mask of 0.0.0.3, because it's a /30 area here is area 0. Should also establish neighbor adjacency, and the status should change to a full state. So you see the status has now changed to a full state, means that the LSS has been exchanged. Now let's see in our network now with the OSPF configured. Now will these PCs be able to ping each other, and also is it that this router can it be able to reach this other router? So just pick there, and also pick another one, another PDU from this one to this point, and we want to see how the network also from this point to this router, also from this to that, again from that PC to that PC. Then you come and simulate. You can see the ICMP here. You come here and simulate and see how the packets will be able to travel and how the packets get verified. So you see how the messages are being sent. The first one here that was sent to this SF router has returned, and it is positive. The second one that was sent to the PC has also returned. Meaning that our network is running properly. So let's go to our real-time modes, and show IP interface brief. You can see the interface has been sent IP address and it is up. Also for the serial is also up. Exit and exit again. Show IP OSPF. When you show IP OSPF here, the process ID is 1 with the ID is the router ID is 192.168.20.1. Remember, we didn't configure the router ID. So if you don't configure a router ID, the router will automatically pick the IP address of the interface with the highest IP address. So either it picks the highest IP address configured on the interface, or if there is a loopback configured on that interface, it will pick the highest loopback interface to act as the router ID. So do show OSPF, show IP OSPF database. When you show OSPF IP OSPF database, you can see here the networks. You have got a network of 10.10.10 and a network of 10.10.10. So while on that router, it can see this network. And it also can see this other network with the gateway of that. So let's try and ping the PC on that other side. So from this LA router, so ping 192.168.10.10. Success rate is, so meaning that we are able to reach this PC from this LA router. But now can this reach upper one there? Success rate is also that one. So also let's log in again. So we said OSPF. We are on COP router OSPF1. Then enable. After that, you also are required to give it a password. So OSPF. Then on that, there are several verification commands that we are going to run on this our router, so that we learn at what we were implementing on OSPF. Show IP OSPF database. When you show that, you can see can see here the router ID here is 172.16.10.5. So like on this router here, you can see the IP addresses that were configured on those interface. On this serial 00, it was configured with 172.16.10.1/30. On this serial 1, it was 172.16.10.5. On this one was 10.10.10.1. So it will pick the IP address of the highest IP address of those interface, which was 10 dot not 10 172.16.10.5. So as you can see here, it has picked that as the router ID of that router. So then this one just tell you the neighbor. The neighbor here will be that one. Then after that, we show so IP OSPF, show IP OSPF interface. When you use the show IP OSPF interface on serial 0, the protocol is up. Then the address is 172.16.10.1 and it's on area 0. The process ID here is 1 that we set on that. Then the router ID is this one that will be selected with the highest, the interface with the highest IP address. Then remember here, the network type here is point to a point because we use the serial interface. A serial interface is a point to point. Then the cost here is 64. State here is point to point. Then the interval here is 10. Hello interval is 10. Then the dead interval. The dead interval is the time that is waited until when the interface will be considered to be down. Now, when we come to serial number 1 here, also the same internet address is that one. The router ID is that. It is a point to point with the same cost. Then also the state is point to a point. The hello and the dead time are the same. As we continue, we are going to identify something here. Now we get to gigabit 0. Gigabit 0, the status is up. The line protocol is also up. And the internet address is 10.10.10.1 and it's on area 0. Then process ID is 1. Router ID is the same as the one or those serial interfaces. Then now here, the network type here is a broadcast because this one is an Ethernet interface. The process is broadcast. Being a broadcast, once there is a broadcast, there will be a DR election on those interfaces. So that's why we see here the status is now the DR and the priority is 1. The other one, the state was point to point. We know that a point to point link doesn't participate in the DR election. So because this one, the other one is a Ethernet interface, it will participate in the DR and BDR election. So this one here will act as the designated router with the router ID. The designated router will pick the router ID, so that one will act as the designated router. Then the internet will be that. The internet address will be that. Then the backup designated router will be 10.10.10.2. So that is the interface on this bold router. So it is the one that will act as the backup designated router. So this link that connects these two routers is an Ethernet, a gigabit Ethernet link. So with that, meaning that it is a broadcast, and in a broadcast, we elect the DR and the BDR election. So why do we need a DR and BDR election? The DR and the BDR election help reduce the adjacency in our networks. So with that said, I will have to continue. So the hello is 10, the dead time is 40 as on the other one. After that, the next thing we do is now is we are going to show IP protocol. When you show IP protocols, you can see here the routing protocol here is OSPF. So the routing protocol that run in our network is OSPF. Routing for the networks that were advertised are these networks you can see here on that router. That is 172.16.10 with that, and also with the routing we have got here the gateways, then the distance here. So we know with OSPF the default distance is 110 as it is telling you here. Distance here default is 110. You should also know the default for the other routing protocols like the RIP and EIGRP. So with that, we can also do the same on this other router. Enable. After enable, now tell it or show IP OSPF interface. When you show OSPF interface, you can see now here gig 0 is up and the protocol is up. Internet address is 10.10.2. That is the address that was configured on that interface. Then area is 0, process ID is 1, router ID is 10.10.10.2. That is the address on this interface. Only that interface, that address was configured, so it will act as the router ID. The network type is a broadcast. The cost is 1. Designated router will be the IP address of the highest configured IP address. That is the router ID on the COP router. The interface address here will be 10.10.1. That is on the interface address of the DR. Then the backup designated router will just be itself. That is the router we are on. Then others are just hello time and the dead time. But I believe what we've implemented on OSPF, guys, you've understand, and that's about how you can configure a single OSPF area. So in our next lab, we are going to configure multiple OSPF. So we are going to see how can you now configure several areas in our network, and why do that help. When we configure multiple areas, it will help reduce the size of the OSPF routing table. Like for instance, in single area here, the OSPF routing tables will be full, but when we configure several areas, now the size of the routing tables will be reduced, because each and each different area will help now share the routing table. So with this practical, I think that's was this simple area. The configuration that we have done are just enough, and let's just stop there and meet in our next lab. That is will be very interesting lab. That is multiple area OSPF. So thank you guys, and uh, remember to subscribe if you haven't subscribed yet. So thank you, and let's meet in our next lab.